Good morning, everyone. So, if you're able to hear my voice and see my screen, please type Y in the comments. Okay. So, I hope my slides are visible. I'm just checking once again. Please type Y if you are seeing the slide. Yes. Okay. So now, if we uh, recall our first few lectures, we talked about the syllabus and what is my intentions. So most of the signal processing part we have covered. We have covered most of the signal processing part. Now the focus of our remainder of the semester, let's say till mid-sem, we have covered whatever is necessary. The second half of our course will be focused on machine learning for speech applications. This will be the focus of our course. So you have your mid-sem. I think a few days, only 10 days left or so. I do. So I will not what is called take new topics in this week. I will start with introduction of machine learning today and tomorrow, and then on the third day, on Thursday, we'll revisit, we'll recap all the topics that we have covered in signal processing. And immediately after midsem, our entire focus is going to be on machine learning for speech applications. So I don't need to tell you much about how important artificial intelligence is, uh, how important machine learning and artificial intelligence is. Artificial intelligence has a wide range of domains that come together to provide machines with the capability of learning by themselves. So a big part of artificial intelligence in implementing intelligence to make machines not dependent on rules but dependent on what is called but having the ability to learn from data. That is, those techniques, those set of techniques, those methods are called machine learning. And one particular set of techniques that has come up due to the evolution of GPUs, graphical processor units, in the last 10 years is neural networks and deep learning, more popularly known as deep neural networks. So please remember that this entire field of computer science, it is artificial intelligence is not a branch of computer science exclusive to it. It's because of development in electronic hardware, that is GPUs. Those who play games, those who are aware of, those who have built their own computers from scratch, those who know the components of a computer, they have built the desktop computers, they will know what I am talking about, what is GPU, what is CPU, and the relative terminology, the basic know-how of what the constituents of a CPU are, what is a motherboard, what is north bridge, what is south bridge, and all that, which everybody should know. But it's okay if some of you are not aware. That's okay, you can always learn and become aware with time. But the evolution of graphical processing units in around 10 years ago, to 10, 11, 12, from NVIDIA and AMD, that is the reason why you have very high-end games now. And those GPUs were later found to be extremely effective in implementing these deep neural networks. And that is why the entire field of artificial intelligence, which has now become almost synonymous with deep neural networks, when somebody says AI, it's automatically almost people are saying that this means he's working on DNN and all that. So it's because of the evolution of computer hardware. So I will just share a video. Let's watch a simple video about what is AI, and then we'll see another video about a prominent scientist called Ben Goertzel. You will get a very good overview of what is going to happen in the near future and where are we going towards in this age of AI, so to say. So in the chat, I have given a link. Go and watch that link. It's a 4 or 5 minute, 4 or 5 minutes only. Just come back by 10:15. Then I will share another link for you to watch. Come back by, say, 10:16. So welcome back. I hope you finished watching the video. Please type Y if you're back. Yes. So this gives a good overview of what AI, artificial intelligence is. Very short video. Of course, there is much more. You have to start with neuroscience also. Means really, it has even fields of biology are related. You must understand how the brain works, or try to at least get a good grasp of the workings of the brain, and then implement it to achieve what is our current stage AI. That is what deep learning and all this are based upon. Anyhow, so I will share with you another link now. It's a 45-minute interview with Dr. Ben Goertzel, who is both a very fascinating and a very important scientist of our generation, and also a very dangerous person in my personal view, because he works for the CCP, the Communist Party of China. So who knows what's going to happen? But he is a brilliant scientist. And robot Sophia that you might have seen, it's his creation from his company. And it's based on his company is based in Hong Kong. I think it's called OpenAI or AI, something like that. I forgot the name. So, but it's a very important, a very fascinating interview regarding what is AI going to bring forward in the current few decades, let's say. So that is why I have been telling you this course, speech technology or speech signal processing, is a very important course, particularly for people who are interested in technology and research. So let me share you that video. Come back by 10:45. Sorry, yeah, 10:45, and then we'll conclude the lecture. But the video will not complete. Take your time, watch the video. There is also a second part, for which you'll have to go to the particular website, and you can see that entire video, the second part, for free there. So let me share that video link with you. So hello. Yes, I think we are 10:50 almost. So please give your attendances and watch the videos. Tomorrow we'll cover the basics of machine learning, and the next class we'll uh, review the course done till now before the midsem. So please exit the lecture. Good morning, everyone. If I am audible and you can see my screen, please type Y in the comments. Okay, fine. So, yesterday, I hope you went through that interview regarding one of the scientists in AI. So, today we'll discuss, we'll see a few short videos, and then I will discuss how we use uh, machine learning in speech application. We'll take a specific example. So let's start with a simple video regarding what is machine learning. These are all YouTube videos which are easily available. I have chosen the ones which are I found very clear and concise. So please go to the link I have provided. I think it's yeah, it's a 8-minute video. So let's come back by uh, 10:13. Okay, 10:13. Let's come back by 10:13. I will also watch it here. Uh, so I hope you have returned. It's 10:14 now. So basic idea. I hope you got what is supervised, unsupervised, and reinforcement learning, which is a little bit, let's say, related to robotics kind of stuff. But let's focus on supervised and unsupervised learning. So it's label data. A simple example, a simplest example you can take is that if you are asking your computer, your algorithm, to identify different fruits. Now you could give images and you give them the labels. You could give images of multiple, many images of different oranges, let's say, and you give you also tell it that this picture is that of an orange. Similarly, you will give pictures of different let's say apples, and you will also tell them this is an apple. And then the machine, the algorithm, how it extract features from that images and uh, connects it to that label. That's the capability of the algorithm that you have designed or that is out there. So now when you have a label, it's almost like teaching a kid, a small baby, oh, this is an apple, this is orange. It's like that, hand holding. But after some time, you expect that after some time of hand holding, which is called a training phase, if you give an image, it should be able to identify correctly what type of fruit it is. Obviously, then fruits you have shown in the training phase, only them it will be able to correctly classify, or you will expect them. If something else comes out in the testing phase, if you give some arbitrary fruit which you have not trained it for, then it will obviously give bogus results. Now there is another, as we said, unsupervised learning. Imagine I have this real life example, if you would like to maybe even investigate yourself. You see, pollution, plastic pollution is one of the biggest issues all over the world. So the coastline of India and other third world countries, it's very polluted. Now, if you take satellite images from ISRO and try to find out which areas of the coastline or near our coastline, which areas of the seas or oceans are most polluted. Now, there is no way to give it a label. How do you know if you take a satellite image that you cannot simply start labeling each and every coordinate and all? So based on certain features, let's say for example, reflective index or refractive index, something is changing, some salinity here and there, you take samples and some features are there maybe because of plastic that has changed in the ocean. So if there are some algorithms, they can find clusters in the map, in the satellite map, saying that these areas look different from the surrounding areas. That is unsupervised learning. Unsupervised machine learning, or also known as clustering. So let's watch now another video. It shows a step-by-step process in a machine learning algorithm. So let's watch that and then we'll come back. So let me know if you are all back. Okay, so we are all back. So then let me, I hope you understood most of the stuff. It's quite preliminary, but quite important. So, well, let me then focus on uh, supervised learning. Let's talk about where supervised and unsupervised learning will come in the context of speech processing. Let me take a simple example. Let's take uh, speaker recognition as an example. Speaker recognition as an example. So what is the goal of speaker recognition? So there are multiple speakers. There are multiple speakers who are speaking with recorded sentences, recorded utterances you have collected. It could be some random phrases, or it could be a single phrase that could be that has been recorded multiple times. But let's stick to the finally the thing is that we have multiple speech utterances from different speakers. Now, generally, unfortunately, in academic scenario, if you see uh, what happened in the earlier video, the Google executive, the instructor was talking about imbalanced data set. So in academics, let's say lots of girls are there. Lots of boys are there compared to lots of girls. So if I create a data set from our university, any other university generally, in technical domains, women are not there. They are there in maybe healthcare or maybe finances. They are heavily they heavily outnumber men. But in technical engineering domains, women are not present compared to men or boys. So when you collect data set, you will find lots of boys, or most of them will be around 70% men or boys, and only 30%, let's say, women or girls. So you have to make sure that this imbalance of data set does not affect your final machine learning process. But keeping that aside, you have different speakers now. You have a set of some, let's say, in your class, let's say 80 students are there, or let's say 100. Let's take a round number. There are 100 students there. So all of you speak certain phrases, and we have recorded those phrases. Now, from each of them, from any any utterance, whoever is speaking does not matter. We have to do something called feature extraction or feature engineering. So what does that do? So the goal is to extract. You see, I told you before, an 8 kilohertz speech signal. That means 8,000 samples in a 1 second speech signal. It's obviously no computer will be, if you have a even a 1 minute in total. Let's say if all of this sentences you have spoken are around 5 seconds, even 50 10 sentences, 10 recordings of your voice we have, then it's going to be such a huge number of samples. You cannot expect the machine learning algorithm to uh, just process so much data and so efficiently. And it is also of not much use, because the goal is to recognize patterns in your voice which identify you. Giving each and every sample is not going to benefit any machine learning algorithm. So the feature extraction process, generally what we do is, now our go-to features are the MFCCs. You can also append it with linear prediction coefficients, or even your fundamental frequency if you estimate. But let's stick with MFCCs. So we have discussed we can have 13, generally 13 dimensional MFCCs plus 13 delta coefficients plus 13 delta delta coefficients. Let's say 39 dimensional MFCCs is generally a very standard feature set for speech. So every frame, whatever speech utterance you have, for every frame you will have 39 dimensional features. So this is frame 1, frame 2, frame 3, frame 4, like that. All of them are 39 dimension. Now out of these frames, in fact even before doing this, in the after framing, you can select those which are silent. Those are silent frames, and you just reject it. You don't extract MMCCs for them. The rest of the frames which are not identified as silence, not silence, only for them you keep them. We are not bothered about in this particular application. We are not bothered about what is called the exact sequence of the exact sequence in which the frames come. For example, certain frames are there, in between we remove the silence, obviously the sequence is broken, but we are not bothered about that. Speaker recognition is not affected by this sequencing. In speech recognition, it becomes very important. So we have now, let's say for a 5 second speech signal, you have got, let's imagine, ultimately after removing all the silence frames, you have a 5 second speech signal. You have MFCCs, 39 dimensional MFCCs. Let's say, just imagine there are 1,000 frames overall. And this is the feature number 1, 2, 3, this 39 features. So now we can, so if you represent this, this is like a 39 dimensional vector. Each of this represents a 39 dimensional vector where each one is a dimension. There are 39 dimensionals and there are 1000 vectors. There are 1000 data points. And there are 39 dimensional data or features. 39 dimensional features, and these features are and there are 1000 data points for this 39 dimensional features that we have got. Now obviously this is only for one speaker, one utterance we have taken. Here if he has spoken, if we have collected, let's say 10, 20, whatever, uh, you can assume, let's say on an average, let's say every utterance he spoke has finally 1000 data points. If we have collected 10 of them, we have got 10,000 data points for him, 39 dimensional. So that becomes his speaker space, or these entire 10,000 data points becomes the speaker space or feature space, whatever, all are the synonyms for that particular speaker. So I am only showing here, let's say, this only 3 dimensions out of 39. I am hypothetically plotting. So you can see that for a particular speaker, there will be clusters. Any particular speaker, there will be clusters. That there some data point, these data points will form certain clusters. Speaker 2 will also have certain clusters. It will be very close to, some will be overlapping, but some will not be overlapping with speaker 1. Speaker 3 will again have clusters and all. So now this 10,000 data points is also a large number. So we use clustering. We use clustering methods to represent this 10,000 data points into some clusters, lesser number of clusters. Very frequently we'll find some 2 to the power n number of clusters, generally 512 or 1024 or 256, depends upon how much data you have. If you have more data, you can go for more clusters. You will learn about it later on. But even this data, you will do cluster for a particular speaker. Now you have got these clusters. Now you can use a machine learning, you can use deep learning, you can use even like other traditional machine learning algorithms, supervised learning, you can say, that that these clusters are there. Each cluster has certain parameters represented by certain parameters. You can give to a certain deep learning network. This is speaker 1, this is speaker 2, it has these clusters, all this. And the deep learning parameter will have an output: first speaker, second speaker, third speaker, 100 speaker. This is how you train. So this you can say as supervised learning. This clustering process was unsupervised learning. And then as we saw, we keep certain amount of data from each of the speakers separately, which we call for evaluation or testing. And we do the same process, this feature extraction, and till clustering, we do it. And then we feed it to the deep neural network. Sorry, till feature extraction, we do all that part as it is. Then we push it to the unsupervised learning algorithm and DNN to finally Yeah, find out these utterances, this speech utterance, whether it was spoken by which speaker, speaker one, speaker two, speaker three, and all that. That gives the accuracy and performance of your model. So I hope I could give some clarity. uh, we will, as we implement some of these techniques, we will understand better in the coming lectures. So to sum up, we have two basic things in speech processing, two basic categories of machine learning we use. One is supervised learning, other is unsupervised learning or clustering. There are other also forms of, uh, let's say, uh, but again, they come under supervised learning. When you come to speaker recognition that we have seen as an example, we use both unsupervised and supervised learning to create a model for a particular speaker. Similar process you will find in, let's say, accent recognition, emotion recognition, and all those things, or voice pathology detection. In speech, you will generally find both unsupervised and supervised learning combined to form a complete model, so to say, which gives a reliable and satisfactory output or result. Now, in things like speaker recognition, uh, we now generally use really advanced forms of machine learning in the deep neural network category, which we call, I think, which is dependent on context or timing. See, in the case of speaker recognition, we could club all those 10,000 data points for a particular speaker and uttered in different speech sentences. It did not matter. Similarly, for accent recognition and so on, it probably won't matter. But in case of speech recognition, you cannot simply discard and shuffle the frames and all that. Time, the context of time becomes very important. This sound comes after another the previous sound, and there is a link between that. The sound that is going to be uttered after my current sound, there is a link between that. In these scenarios, we used recursive neural networks and long short time memories. These also fall under something called natural language processing. These are all again quite advanced forms of neural networks. We will touch upon them in our lectures in the future, but this is the good starting point of where machine learning is used in speech processing. So tomorrow we will recap the things that we have covered till mid-sem, and then after your mid-sem we will start off with some machine learning applications, machine learning techniques applied in speech processing.